log base 2 of y. Everybody's good? All right, number 4. I feel like we're beating a dead horse. All right. Yeah, okay. So inside the parentheses, I'm going to deal with the fraction first. So I have two things that are being divided. So I need to rewrite those as subtraction. So it's the natural log of AB minus the natural log of C squared. Then I have two that are multiplied. So that's addition. So the natural log of A plus natural log of B. And then I have this power. So that goes in front. So minus 2 natural log of C. You do 5. I'm going to come look at it, so make sure you're actually doing it. I got it. Welcome. Yep. Only thing I do is put parentheses on it. So you just know that it's not all that, right? Yep. Yep. I just put parentheses around that plus 2 just so you know you're taking that log out. Yep. I'm going to get you last just now. There except for the 2 in front. Yeah. Just because you're not taking the natural log of each one. Yeah, that's what confused me. So you just put parentheses around that. Okay. Oh, okay. All right. Yep, just put parentheses around the x plus 2 so you know it's not the natural log of x plus 2. Okay, so on top and bottom, actually, you're dividing here. So this becomes the natural log of x plus 2. And I'm putting that in parentheses because you're taking the natural log of that whole thing. So it's not confused with that. That means you're taking the natural log of x and then you're adding 2 to it. So those two are not the same. Then minus natural log of x squared because they're divided. Now I can't take the natural log of each one of these because it's not the natural log of 2 times x. That's when you can separate it out, is when they're multiplied together. So then this 2 can become a coefficient. So it's the natural log of x plus 2 minus 2 times the natural log of x. All right. Okay. Same type of thing. We have division. So it's log base 2 of 2ac, you can put parentheses around it, wouldn't hurt, minus log base 2 of the square root of e. If you're not sure when to and when not to put parentheses, you can always put the parentheses after log. It's not going to hurt. then you are taking the natural log of 3 things multiplied together. So that means you're really taking the natural log of each one and adding them. So the difference between doing that and not being able to do it here is because here it's added and not multiplied. And then square root of d means d to the 1/2. So we can put that 1/2 out here. And then it's been expanded. And then, you guys know surely by this point, you can always tell me, whoa, I don't have that right. Okay. So then again, these are divided, so we rewrite it as subtraction. And then we can put this power out in front. And then these two are multiplied. So I'm putting a bracket here because I'm supposed to subtract all of this that's behind it. And in here, 2 things are multiplied, I'm adding them. So that's log of y plus log of z. And then just don't forget, I'm subtracting this whole thing. So I have to subtract both of those. So it's 3 log x minus log y minus log z. A lot of people mess up on that second minus sign. I'll put a plus there. Okay. So we've just been practicing using these properties. We've been practicing squeezing them together and pulling them apart. Now we're going to use that information to be able to solve equations with logs. Okay, so here's the next one. The directions say to solve by rewriting each side as a logarithm, a single logarithm. Set them equal, and then on the other boxes, we're supposed to check the solution. And if it has no solution, explain why. All right. So first off, we have 2 logs that are added together. So I can rewrite that as 1 log. Oh, wait. I say first of all, I should have done this 2 first. That's a power. So it's log of x plus log of 2 squared, which you can go ahead and write as 4. Over here, I really can't do anything with it because they're added, not multiplied. Now, when I have 2 logs, separate logs that are added, then what can I do with those? Those I can multiply. So I have log 2 squared is 4x. So here's somewhere where I need to be careful with how we say things. You cannot say, oh, well, these logs cancel out, because they don't. But what we can say is, since you're taking the log of a number and it's equal to the log of a number, those 2 numbers have to be equal to each other. So logs don't cancel, but it's just because the logs of certain arguments are equal, that means those arguments have to be equal. So 4x equals x plus 9. And the reason why I say logs cannot cancel because they're an operation, not a number. Subtract x from both sides, you get 3x. Divide by 3, x is 3. Then we're supposed to check it. You'll see a reason for checking probably Monday. It's log of 3 plus 2 log of 2 equals log of 3 plus 9. So that's the log of 3 times 4, which is 12. Because remember, that's a power. And a log of 12. So yeah, it checks out. Most of these things we're not going to check out on paper. We're going to look at them and figure them out, because once you see where the issue is, it'll be quite easy to tell. I guess that's really a good place to stop. So the bell rings at 10:23. We'll finish this up and probably move on Monday, so don't put off homework and stuff.
How many more weeks of school do we have left?
9.
Oh, yeah.
I say it like that because of my son.